Here are the vector skills you're going to need for physics. Pay attention to directions. This is going to be the big deal for today. Always, always include your arrow. Here's the first. Here's the second. And we can see the resultant here coming straight out of a 3, 4, 5 right triangle. If you want to express this final displacement in bracket form, here we go, horizontal, vertical, and don't forget the unit. If the question doesn't ask for magnitude and direction, you're home free, but if you want or need magnitude and direction, the magnitude here is clearly 5 meters. It's a 3, 4, 5 right triangle. But direction in physics is measured from the positive x-axis. So if you're going to find your reference angle, this is the one you want. This one here will be useful for your bearings. Reference angle is 53.1 degrees, which doesn't tell us anything unless we lose the bearings. This is south. Theta is touching the south, so that's south. 53.1 degrees, left, right is going left, that's towards the west. If you had found this reference angle up here of 36.9 degrees, up here, that angle is touching the western axis. So an additionally correct answer is west 36.9 degrees south. Final displacement in polar form would be 5 meters at an angle of 90, 180, additional 36.9, that's 216.9 degrees as measured from the positive x-axis. Round that to about 220 degrees-ish for sig figs. Component form. Here is our flight vector, northwest, infinite number of sig figs. I hate it. Nevertheless, they give us a nice 45-degree angle here. So this angle, as far as physics is concerned, is 135 degrees. X component. Don't leave off the arrow. That's v cosine theta. Y component. Don't leave off the arrow. This is west, this is north. That's sine. This is where it's important to get the proper math class angle in relative to the positive x-axis. This is clearly west. So your western component is going to be about negative 106 kilometers. And your northern component over here, second quadrant, that's going to be about positive 106 kilometers. East, that is bracket form, goes first. We are not east, we are west, and our bracket form ought to make that patently clear. Now, if you're given bearings, no problem, sketch them out, convert to proper math class angle. This is southwest. The bearings you've been given are south-southwest, halfway between south and southwest. That is 270 degrees minus 22.5. That's 247.5 degrees. Now we can find vector components. Again, don't forget your arrow. There is west. Don't forget their arrow. That is south. Notice we're building off the x-axis where we possibly can. The question asks for the y component. That's d sine theta. That's about negative 2.3 miles or so. That means the boat is about 2.3 miles south of the harbor. Now that we know how to work with vectors, note that every time there's a vector sign here, this isn't just check the direction for positive and negative anymore. Now we have lots of directions to check. Not only forwards and backwards, up and down, but north, south, east, and west. All of these are vectors. Velocity is a vector. Acceleration is a vector. Time, well, that's a scalar. That we can multiply by. All right, this isn't so bad. Final velocity, that's our answer. Initial velocity, 16 east. That's 6 16 horizontal, no vertical. Acceleration, 2 north. That's 0 horizontal, 2 vertical. But this is multiplied by t. T is a scalar. It's multiplied by a scalar of 4 seconds. Okay, we can do that. 2 times 4 is 8. So our final velocity is going to be the vector sum of 16, 0 plus 0, 8. Final velocity, and they didn't say anything about bearings or magnitude, so we can leave it in bracket form, is 16 meters per second east and 8 meters per second north. Why didn't we have to do any of this before when we did one-dimensional motion? Because it was always east and west, never east and north. Now that we have east and north, we're going to need to use the Pythagorean theorem and the arctangent to see not only our magnitude, but our new direction, which is not going to just be forwards and backwards. Now let's try more advanced kinematics. Let's try the left turn. Here you are going west, your initial velocity, and you wish to turn so that your final velocity is going south. You wish to apply your acceleration for a certain time to make that change. The definition of acceleration is your change in velocity, note vector, over your change in time, note scalar. That's all right, we can divide by a scalar. We can divide by 4.5 seconds. That's not so bad. We're dividing the difference between our final velocity, 12 south, and our initial velocity of 12 west. Note negative signs in both cases. What do you get? Well, you need to lose your western velocity and gain your southern velocity. You're going to end up with about 2.7 meters per second squared of eastward acceleration, combined with 2.7 meters per second squared of southerly acceleration. Note negative because south. If you were programming the computer for the driverless car, this is how you would tell the car to steer itself. Now, let's put those vectors together. BD and Fred are lost in the jungles of Vietnam, where they have to put aside their political differences to survive. They start by hiking southwest. Then they get turned around and hike another 5 miles north. Where are they now? They have no idea. Even I have no idea because I don't even know for sure that we're in the second quadrant. I'd like to think so, but I can't be positive. We need to add those vectors and find the resulting displacement. I prefer the component method, breaking each one of these into components and adding those components to find our resultant. We have south, east, and north. There are our components. Now we add. They are northwest of where they started in the first quadrant, as we guessed. There's the west, there's the north. If you want the magnitude, use the Pythagorean theorem on these two components. That's about 3.6 miles. To find the angle, our reference angle is going to be this one here with the positive x-axis. The calculator running the arctangent function is going to give you about negative 37 degrees. Notice the quadrant is wrong. Negative 37 degrees is over here in the fourth quadrant. It's telling you to subtract 37 degrees from 180, where you are. So of about 142 degrees, or a bearing of west 37 degrees north.